Okay, stats. We are going to finish up notes for section 7.1 today. We only have one example left. But before we do that example, I'm going to go through homework problem number 7 with you just to give you one more kind of confidence interval thing before we do something that's a little bit different for example 5. Okay. And then what I'll have you do for homework is just the rest of the second page. So 8, 9, 10. Do that for homework. Add that to your first page here. But we'll do number 7 together. Okay, so this one says, in a study of cell phone use and brain hemispheric dominance, an internet survey was emailed to this many subjects. Okay, hold up. That's what how many were emailed. It says this many surveys were returned. Okay. Okay. Construct a 90% confidence interval for the proportion of returned surveys. Okay, so we're talking about who returned the surveys. We're talking about p hat is the returned surveys. That is 1,000 over the 2,300. So 10, 16. This is a scenario of when they don't give you what p hat is, which is kind of interesting. Okay, all right, I'm on a dumb calculator. I have my phone to help me, so you're gonna have to bear with me while I type this in really slowly. Okay, this is 0.442, let's say. It's like 0.4417. We'll go 3 decimal places, 0.442. I'm going to go ahead and find out what Q hat is because we're going to need it. Is 0.558 is what Q hat is. Now, N is not the number of return surveys, it's the total number of subjects that we sent out. Okay, so that's 2,300 is what N is. All right, find the best point estimate for the population proportion. If I would send out surveys to every single person, I don't know what percent of people would return them if I surveyed everybody. But the only number I have to go off of is that 44% of people returned surveys in my sample. So the best point estimate is going to be 0.442. Okay, now we need to find the margin of error, and error is that z, they call it z of alpha over 2, but the alpha over 2 is just like part of the notation that they use. Square root p hat q hat over n, okay? And we want to construct a 90% confidence interval. So we need to use that 90% to figure out what z is, okay? Z for a 90%, if you look up in the bottom of your chart, the bottom right corner, it is 1.645, okay? So when I'm writing this out, I got 1.645 times the square root of p hat is 0.442, q hat is 0.558 all over 2,300. And I'm going to type this in really slowly into my stupid phone calculator because that's all I have. I forgot to bring my others home. 0.442 times 0.558 divided by 2,300. And then I want the square root. And then I want to take that times 1.645. And I got 0.017, which is 1.7% for a margin of error. Okay, now we haven't talked yet quite about what is considered to be a decent number for margin of error. Typically, your margin of error is going to be a number less than 5%, okay? And if it is more than 5%, it's probably going to be like less than 10%, okay? Margin of error is never usually terribly big. And we'll talk about here in a second what affects your margin of error the most, okay? But 1.7% is what I get for that, okay? Construct a confidence interval. So I don't know if I would survey the entire population, I don't know what percent would return them. 44% of my sample returned them, but I can say that if my margin of error is 1.7%, I can add and subtract 1.7% from my 44.2. So 44.2, I'm going to add and subtract 1.7%. I should write that down here. Sorry, I'm going to move it. I should move that. I'm going to move it over here. Okay, and when I do that, I get like 45.9%, and I get I can't subtract that in my head. Why can I not? Yes, I can. 42.5%. Okay, that's what I get for that one. So I would conclude that I'm 90% sure you're going to cause problems. 90% sure that if I would survey the entire population, somewhere between 42 and 46% would send them back. Okay? All right, write a statement. Oh, that's what this next one. We are, okay, here's what your statement's going to look like. Write a statement that correctly interprets the confidence interval. We are 90% sure, or I'm going to say confident, 90% confident that if we surveyed the entire population between 42.5% and 45.9% of people would return the survey. Okay, so it's your interpretation needs a couple different things. It needs how confident you are, it needs the percentage that it falls between, and then it needs what you're talking about. Okay, and and it needs the entire population, the words entire population. So make sure you have at least those three things in there, the four things, I guess. The fourth being what it is that the story problem is telling you. So confidence, mention in there that you're talking about the entire population, percent that it would fall between, and then what it is that you're talking about. Those are things that you need to have in your interpretation. Okay, so that was that. Now let's go back to example 5. And example 5 says this. Okay, we're talking about making online purchases. So what percent of adults make online purchases? I'm going to write some stuff down below, and let's read through the paragraph. When the author was conducting research for this chapter, he could find no information about the percentage of adults who make online purchases. Yet that information is extremely important to online stores as well as brick and mortar stores. If the author were to conduct his own survey, how many adults would need to be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? Blah, 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 blah. What? That was confusing. We're talking about margin of error, and error is z of that alpha over 2 times the square root of p hat, q hat over n, okay? And they give us some information on part A and B, so maybe we should look at that stuff also. But things that I know from the paragraph, how many adults must be surveyed? That is what we don't know. How many adults? That means we're solving for n. Okay, n is what we don't know. In order to be 95% confident, okay, 95% confident, that's going to tell me that my z value is 1.96. I think that's what it is for 95%. I don't remember. Let's see, 95%, 1.96. Yep. So my z of alpha over 2 is 1.96, okay? And I want my error to be no more than 3 percentage points, okay? So I'm going to put 0.03 here, okay? That's what 3% is, 0.03. All right. Now, in part A, it says assume that a recent poll showed that 80% of adults make online purchases. That's what my p hat is going to be, 0.8, 80%. That means q is going to be 0.2. So we're going to just do this, and we're going to unwind this equation. Let me write it down better. 0.03 equals 1.96 times the square root, 0.8 times 0.2 over n. We're going to solve for n there, okay? All right, so first thing I'm going to do to solve for n is I'm going to divide by 1.96. I'm going to get him gone, and I'm going to divide him to the other side. 0.03 divided by 1.96. And I got 0.015, something like that, right? 0.0153 equals the square root of 0.8. 0.8 times 0.2, by the way, is 0.16. I'm just going to do that in my head, okay? Now, I want to square both sides, so I'm going to do that. I'm going to take him, and I'm going to square him, okay, which is a really small number, 0.00023, and I get 0.16 over n, okay? And then I don't see where my answer button is. Okay, what I'm going to do is if I'm trying to solve for n, I can switch these two places. Or in other words, I'm going to like multiply by n here to get them to go to the other side, and I'm going to divide by the 0.23 or 0.00023. So n will be 0.16 divided by 0.00023, okay? And that will tell me how many people I need to survey. Okay, so let's see what I have here. I don't know if I can do that. Shh. What? Where's your sippy cup?
Yeah.
Honey, I don't know. I got 695.65. Okay, and I hope that's the right number because I rounded this decimal off instead of using the whole decimal number because my calculator won't do it. But when you're doing these problems, put a star. Always round up. Okay, even if this, so we should survey, our sample should be 696 people, but even if this was 695.1, okay, if I only do, if it says 695.1 and I only do 695 people, my error is going to be like 0.031, and I want it to be less than 0.03, okay? So you always have to round up and do one more person, or round your decimal up to one more person, because that will reduce your error and make your error less than 3%. Okay, here's the deal. When you are trying to calculate your margin of error, the biggest indicator of your margin of error is the number of people you surveyed. Typically, the more people you survey, so as you increase, I'm going to say increase the number surveyed equals decrease your error. Okay, the more people you survey, the less error you have. Now, that comes with a give and take, because, you know, you want to have the least amount error as possible, but I don't want to waste all my time surveying tons and tons and tons of people. So, you know, you've got to give and take there. I've got to allow a little bit of error because it's going to save me time in the long run surveying fewer people. Okay, so you've got to decide the balance there, what you want to do. Okay, part B says, assume, this is the last one, assume that we have no prior information suggesting a possible value of a population proportion. That means we don't know 80%. Okay, so here's the deal. We don't know what p hat is, which means we don't know what q hat is either. So when we do this, we know that we want 0.03. Our z is 1.96, but I have no idea what p hat and q hat are. And when that happens, we're solving for n, you are going to default to 0.5, okay, for each. So p hat unknown, I'll say p hat, q hat unknown. Use 0.5, like 50% for each one. When that happens, when you don't know p hat and q hat, you use 50%, okay? So that's what they're saying for part B. We don't know that it's 80%, we're going to do this. Okay, so again, divide by 1.96, divide by 1.96. I had that number over here. It was 0.0153, and then I'm going to square it, so I get 0.00023. Because I squared it over. But this number now is 0.25 instead of 0.16 like it was here, okay? So I'm going to say n equals 0.25 divided by 0.00023. And now, when I have the 50-50, now my number is, I have to survey 1086.95. And again, we always round up, so we've got to survey 1,087 people instead. Even if this was 0.1, we would always round up, okay? Because I want my error to be 3%, not 3.1%, just 3%, okay? So there's how that works. That's what, like, example 5 would be, okay? Now, really quick, how do I want to do this? We could come up with a, let's do it. I have error. let me make this easier for you, z times the square root of p hat q hat over n. Okay, here's the deal. If you're solving for n, you're going to do all the same steps all the time, right? It's going to be like e divided by z, right? You're going to take that and you're going to square it to get rid of the square root. And then you're going to, that's equal to p hat q hat over n, right? Then you're going to swap places here. So if you're looking for a formula where you don't have to like redivide everything and stuff all the time, n is equal to whatever p hat q hat is divided by e over z squared. This is going to get it for you. Okay, so you don't have to do all the same steps over and over again. You can just plop it into there and that will solve you your n for you. Okay, it's just the same formula rewritten. All right, so there's that. Okay, you can even write it a little bit different than that, but I'm going to leave it like that. Okay, so there you go. Do the bottom half for homework. If you haven't done the first page, there you go. And that is all that I have.